Alright, so now we're going to look at a second example of when work is done by a varying force. And what we did for the first example was we looked at the incremental work as being the force multiplied by some incremental distance, some increment of distance. So we had the force and we multiplied it by some delta x, some small increment of distance. But there's another way of approaching this. We could define the incremental work as an incremental force instead over the entire distance. And in that case, we'd be looking at delta F over the entire distance x. And this way of looking at it works well when we're dealing with non-rigid objects. So for instance, consider a chain, a 20-foot chain that weighs 3 pounds per foot. So that's actually kind of like a density, a weight density, hanging from a winch 20 feet above the ground. Find the work done by the winch winding up 1/3 of the chain. So 1/3 of the chain. This is actually going to be able to be broken down into two parts. The bottom 2/3 of the chain, the bottom 2/3, which is 2/3 of 20, 2/3 of 20 for its length. So the length of the bottom 2/3 of the chain is 2/3 of 20, or 40 thirds feet. So that much chain is actually being moved by a constant force. Because that much chain is not actually going up into the winch, so it's being moved by a constant force. So there are two forces working here. The constant force required to raise the bottom 2/3 of the chain, and the varying force required to raise up the top 1/3. You see, the bottom 2/3 of the chain never actually goes onto the winch, so it's going to have that entire weight hanging the entire time, while the upper 1/3, as the winch is winding up, pieces of that upper 1/3 are actually going onto the winch, and it's actually decreasing the weight of the rest of the chain that's being lifted to that same height. So the weight here is varying while the weight down here is constant. So here we have a varying force, here we have a constant force. Let's calculate the work done by the constant force down here. Well, since it's a constant force, all I have to do is figure out what the force is and multiply it by the distance that much rope or that much chain travels. So let's see, since the chain weighs 3 pounds per foot, 3 pounds per foot is the density, and I know I have 40 thirds feet of chain, 40 thirds feet of chain, this calculation will tell me how much the bottom 2/3 of the chain weighs. If I take this weight and multiply it by the distance that the bottom 2/3 of the chain travels, I'll get the work done in moving the bottom 2/3 of the chain up to that height. And the distance that the bottom 2/3 of the chain travels is actually 1/3 of the distance of the entire chain, which is 1/3 of 20, or 20 thirds. So it turns out that the work done in moving the bottom 2/3 of the chain up 20 thirds of a foot is equal to, what's this equal to? Let's see. That's going to be, the 3's cancel, and we get what here? 800 thirds, and this is 800 thirds foot-pounds. 800 third foot-pound. So that's the first part. Now the second part is the work required to move the top 1/3 of the chain. Now, since we've already calculated how much work is done for the bottom, let's just ignore that for now, and let's just focus on the top 1/3 of chain. The top 1/3 of chain. So let's look at this now as being just the top 1/3 of chain, which is actually a distance of, this entire distance here would be from 0 to 20 over 3, because the top 1/3 of the chain is only 20 over 3 feet long. And now we're going to calculate the work done here. Well, what we're going to do is we're going to look at a little piece of chain and calculate the force needed to move that little piece of chain all the way up the winch. Okay, so let's calculate that work. Let's see. Well, the weight of that little piece of chain, the weight, which is going to be our force, is equal to, well, it's 3 pounds per foot, but I'm multiplying that by the number of feet that thing is, and that number of feet is just a little small increment of the total distance, which I'll call delta y. So the weight of this little section, well, the number of feet in this little section is delta y, while the density for the weight is 3 pounds per foot. So if you multiply 3 pounds per foot by that many feet, you'll get the force or the weight of just that little piece of chain right there. And what we want to do is we want to look at what the distance is that that little piece of chain travels to get all the way up to the top, or all the way up to the winch. Well, it turns out that the distance that that thing travels, we're looking at this, the little piece of chain at the very bottom travels the entire 23rd feet. So if you're calling this the origin, then that would be a y value of 0. The bottom piece of chain travels the entire length, or 20 over 3, but if you're a little bit above that, whatever y value you have here, the distance that the chain has to travel, the little piece of chain has to travel to get up to the winch, is actually going to be this total distance minus that y value. So the distance that each little incremental piece of chain has to travel is the y value being taken away from 20 over 3. So as you can see, that's the y value. The y value is how high the little piece of chain is, but that little piece of chain is going to go the rest of the way to get up to 20 over 3. So it's 20 over 3 minus y is the actual distance that each little incremental piece is going to travel. So here we have the force and the distance, and we can find the work done to raise all those little incremental pieces all the way up to the winch. Well, let's see. This is going to be the integral from 0 to 30 over, or 20 over 3, from 0 to 20 over 3 of the force times the distance, which is going to be 3. And then we have this expression, 20 over 3 minus y. And then my delta y is my dy over here. And then we're going to calculate this integral. Well, let's see what we get here. This integral is a little bit easier to calculate if we distribute. So we have 0 to 20 over 3. And then we distribute. We get 3 times 20 over 3 is 20. And 3 times negative y is negative 3y dy. And this is a very easy integral. Let's see. We have, this is 20y minus 3 halves y squared. And I'm taking this from 0 to 20 over 3. Plugging all this in, it turns out that this gives us, turns out to be 200 over 3 foot-pounds. So my total work done to raise this chain, to wrap up 1/3 of the chain, is going to be the work done by the constant force, the bottom 2/3 of the chain, plus the work done by the varying force, the top 1/3 of the chain. And if you add W1 and W2, that's 800 over 3 foot-pounds plus 200 over 3 foot-pounds. 800 over 3 foot-pounds plus 200 over 3 foot-pounds. So the work done in raising this chain, in wrapping up 1/3 of this chain, is 1,000 over 3 foot-pounds. And there you go.